The recovery system is our parachute deployment system that slows our vehicles during descent so that they don't damage themselves upon impact with the ground, so that it's not undergone so much damage at impact that we can't determine what conditions it saw during flight. The way the recovery system works is that we eject the nose cone at apogee, the highest point in flight. And we do that by pressurizing the recovery bay using a CO2 gas canister, kind of like what you'd see on a paintball cartridge. Then the drogue chute, a small parachute that sort of aligns the vehicle during descent, it deploys passively, just unfurls. Then, around 5,000 feet, a main chute will typically deploy to slow the vehicle even more when it's about to hit the ground. However, we've not actually gotten that dual deployment system work in the past. On Deja Vu, the vehicle over there, it saw an apogee deployment of the main, which means it had a lot of time to move away from where it originally launched. It has a huge dispersion radius, which means it's a lot harder to recover. Now, for a vehicle that only went to 20,000 feet, that's not a huge issue, but for a vehicle like Traveler 3, a space shot, it could end up in a different state, and so we need to prevent an apogee deployment of a large chute. Now, to do that on this vehicle, we changed our system dramatically. We switched to a single deployment system where we have a much, much smaller sort of main drogue hybrid that deploys at apogee. And the analytical methods we've used and the simulations we've written have suggested that this will be sufficient for our needs.